appreciate all the participants who have come from various colleges. It is a very unique program organized by Rextra. I also congratulate them and appreciate them for this unique program. Unique in the sense organized for the various students who are the futures of this particular country as well as for the world. And I understand that yesterday's program was very informative and successful. I also heard that you all went with a concern for climate change. It's good that you have developed some concern about the climate change. Don't worry. Today's session will be more interesting and useful to overcome that challenge, because today we will be covering mainly the clean coal technologies. I understand that you all got some concept about the clean coal, how to obtain this clean coal. But today you will be exposed to clean coal technologies. At the end of the session, I would like to hear from one of the participants what you have understood about the clean coal technology. Okay, and our first session will be on polarized fuel propulsion, which forms the backbone of the thermal power systems. As you are aware, around 1,000 steam generators in the country. Most of them are based on polarized fuel compression. In any thermal plant, the first and foremost conversion process is conversion of chemical energy into thermal energy. So what are the conversion processes in the thermal plant? Conversion of chemical energy into thermal energy mechanical energy into electrical energy. Fine. So the polarized fuel combustion is forms the backbone of the thermal power sector. Among 1,000 units, nearly 90% of the units are based on polarized fuel combustion. This combustion method was developed somewhere in the first half of the 20th century, and in India it is ranging from 30 megawatt to 500 megawatt operational. Of course, soon you will be seeing 660 megawatt and 800 megawatt supercritical units in operation. Of course, right now operating units are up to 500 megawatts. And this topic will be mainly covered by our Mr. Shankar Nayak, who is working as senior product engineer in PHL, and he has graduated from prestigious IIT Madras as BTech Mechanical Engineering, and he has got 7 years of experience in PHL, both in conceptual design as well as grid engineering. I wish Mr. Shankar Nayak to cover more on the conceptual design, because we are in the initial stages of the technology. And know him personally also, and he is a very knowledgeable person. I understand that he is having a flair for teaching experience also. His development works include economics and redesign, combined boiler and turbine start generations, fuel gas optimization, etc. You will be interested to know that he is preparing for his IAS exam also. Right, Mr. Shankar Nayak? Let's wish him one IAS from our community. Okay. And it is our proud privilege to hear from Mr. Shankar Nayak now. And we will go to the next session after this polarized fuel combustion session is over. And that will be on fluidized fuel combustion technology, which is one of the clean coal technologies, which will be covered by none other than Mr. Rajvel, who has committed chain research and development for more than 3 decades. We will know about the more during session. Right now, we will go ahead with the presentation on polarized fuel combustion by Mr. Shankar Nayak. Please. Yeah. Go ahead.
Good morning, all. The energy level should be high in the early morning. Clear? Now we'll see what is polarized coal combustion system. Okay? This is very important process in the thermal power plant. Why we have to worry about combustion process? because most of the power plants, not only in India, outside, even in the most of the power plants, not only in India, outside India also, based on thermal concept. So, for thermal concept, what is the backbone? As Sukumar sir already said, this combustion system is the backbone. So, we need to know what is the combustion system, what are its effects, how it will be useful for further processes. Like, because today the more concern is on climate change, clean coal technologies, how to reduce emission, all this. So all these processes are from where it is generating this combustion emissions, all this are coming out of this combustion. So proper understanding of combustion system is very, very essential. So we'll go through in this combustion system so many types of combustion systems. But here I am dealing with only pulverized combustion system. That too basically coal combustion system. So our scope is limited to very small thing actually. If I take combustion system, even in 40-50 days of class also not enough for this coal combustion. But I'll just glance through it some of the basic things and some of the very essential things so that we can understand the combustion process in a broader term. We'll see first. Now, what are we are going to cover in this particular topic? We'll see first. We'll be seeing what is pulverization actually basically. What actually pulverization means, how this is carried out into combustion process. Then we'll see different types of fuels. What are the fuels, how pulverization will take place in each of these fuels, how then later on how it lead to combustion and other. Then one of the main important fuel, coal we'll see. Then what is the coal application briefly, that is not a big thing, but then coal combustion. How coal combustion will take place, how it is different from the other fuel, how it is important to us, all these things. Then we'll see different types of combustion. Like solid means how combustion will take place, liquid means how it will take place, all this. Then we'll be seeing emerging trends in the combustion system. Means what are the trends we are getting in the recent past in combustion system. What are the modifications we are encountering, how we are changing all this. Then finally we will go to some of the aspects of NOx formation and its control. This is the only topic, but a lot of other topics will be there because let us go to it. We'll see what is pulverization. Pulverization means making any big particle into a spying particle, it is called pulverization. Better? How better combustion will take place? Combustion will always take place. Okay, even bigger particle also it will take place. It doesn't mean that bigger particle will not take place in combustion. Take place, but what happens? When it is,
Area of contact.
area of contact of what? No fuel. No fuel only we are making into fine particles. What it will contact? With what it will contact? Oxygen. That is important. So when you make finer and finer particle, what happens is the particle size will become lesser and lesser. So higher combustion efficiency. That results in overall thermal plant's efficiency. So pulverization is the first and the foremost process which increase the efficiency of thermal power. Then we'll go to how it is take place spontaneous combustion. How it will take place, because when a bigger particle is there, it cannot burn automatically. When it is finer particle, it can ignite automatically. So that also leads to spontaneous combustion. Then all these advantages we have seen of pulverized coal. But is there any drawback of pulverized coal or pulverization? Because when it makes into finer and finer particle, what happens? What happens? Huh? Have you heard about nanotechnology, nanoparticles, carbon nanotubes, all these things? Have you heard? What happened? One of the biggest drawback of nanoparticle is that it is very fine in nature. So that what happens, even it will not be appearing in the atmosphere. It can go into your respiratory system. So it can damage your whole body. And you cannot control them also very easily. So that is the biggest drawback of pulverization. But how we are overcoming in the combustion system, that we will see in the subsequent slide. Next. Then these are all the important fuels which we are using. I think I need not go through all these things. This you can understand from very basic. Some of the things only I cover in between. In fuel, solid fuel, that is the main important fuel is coal. So coal will have different types. That we will see in the next slide. Liquid will have LFO, HFO, HSD, all this. If you are having any doubt in LFO or HFO, you can ask me. LFO means light fuel oil, means viscosity will be very less. HFO means high fuel oil, means viscosity will be high. Why we are using different fuels? That we will see when we are talking about combustion of liquid fuel. Then we go to gaseous fuel. Among all these fuels, the gaseous fuels are the most efficient and most spontaneously combusted fuels. So that will give rise to more amount of heat energy for a specific quantity. Next. We'll see. Now the basic important fuel of combustion is coal. This coal is a very heterogeneous material. Heterogeneous means combination of more. What are the combinations of coal? What all it consists of?
Carbon, sulfur.
Carbon sulfurs are all finer particles of coal. But heterogeneous means in a broader level. Volatile also is an inside matter. But silica. Silica also inside only. When you break into coal only it will appear. Sand. Okay. Any other things?
Clay, moisture.
Moisture also inherent. As it is, if it is coal is there, it is not called the foreign material. When it, let us say, if I take coal is formed from where? Mining means from where it is coming? From plant materials, animal debris, all these things go underground and exposed to the very high pressure and temperatures. From where this high pressure and temperatures are coming? Earth crust. From where? Earth crust. If you see earth, there will be some three layers: core, mantle and crust. In core, what happens is high energy will be there in the form of radioactive elements. And in the surface also, it is exposed to the sun's rays. So from top and from bottom, both ways you will be getting the heat. So because of this high heat, this heat is nothing but in the form of pressure and temperature will be there, existing in the earth. That will be transformed into the fuels in the form of chemical energy. So that will be stored. That is what we are extracting here. So with that, coal will consist of lot of material. What are materials? Mineral material consist of, organic material. This is the broader way of coal consist. If you go into finer detail, that we'll see later. So based on this, what all it consists of, how it is, from where it is sourced, based on all this classification, you can divide coals in the world into more than 1200 types. Then we'll see what are the types of coals. We'll have coal based on their carbon content. Why we have to talk about carbon content in the coal? Any guess? Calorific value is very high. If you see all other constants of coal, the carbon's calorific value is very high. What is the calorific value of carbon? Can anybody tell? Remember? Roughly, you need not to be exact. Even I don't know exact value. Okay? 40? Huh? No. Somewhere around 8,000. Okay? Somewhere around 8,000 kilos. That is why if you see any coal, no, almost the Indian coal if you take, the Indian coal will consist of around 40 to 50% of carbon. So that is roughly around half. Okay? So if you take 8,000 into half, how much it will become? 4,000. So in general, what is the calorific value of coal? You can say roughly around 3,000 or 4,000. So in general, you can estimate. You need not have to go to lab and find out all these things. Based on the carbon content, you can directly tell the calorific value of the coal. So based on the carbon content, we are dividing coals into broadly 4 types. That is peat, lignite, bituminous and anthracite. What is peat? Is the first, when coal formed, the first stage is called peat. It will have very less carbon content and high moisture. So what happens? It is not useful for combustion. It can be used, but it is not efficient. Then we will go to lignite. Lignite will have high moisture content. High moisture means how it is a drawback for combustion. So when I talk everything, I link with combustion only. Because my name is only combustion. So when high moisture is there, what happens when the combustion takes place? Heat will be liberated. That whatever the heat liberated, that will be consumed by the moisture in the form of what? You have heard about latent heat? What happens? The liquid will be transformed into vapor phase. In order to transform, it will convert, it will take some energy in the form of latent. So it will be absorbed. Instead of giving, what it is doing? It is absorbed. So more the moisture, what is the drawback? Heat will be liberated, will be very. So you have to, what you have to see is, you have to minimize the moisture. That we'll see later. So in the liquid it is also not very good for. Then we'll go to bituminous, very popular kind of coal. Bituminous coal is having around 40 to 60% of carbon content. So this is what available in India in a larger quantity, and that is what we are doing. So we'll see in detail about this bituminous coal in later part. Then we'll go to honor. Then why we are not using that coal? What is the drawback? Huh? Okay, let us say I will make it available. Why you are not using? I will make it available. Can you make it? Can you use it? No, I will make you available that anthracite coal is available with you. Can you make it combustible? Bit loud and bit clear. No. When you say carbon content is more than 90%, what about the other factors, other fractions will be less than 5 or less than 10 only, no? So in that volatile matter also will be there. That volatile matter is less than 5 or less than 10 as based on the particular. So in order to start the combustion, what you require is you require volatile matter. That matter is not there. That is why we are not using anthracite. Even though if I make it available, you cannot use it much. You have to generate much more efficient combustion technology, or you have to artificially insert some volatile matter into it. Then only you can make it combustible. So that is the drawback of it. So you have seen each and every type of coal's drawback and why we are not using, where we are using, what is. As you have seen, typical, if you see, coal will have two kinds of analysis. One is called proximate analysis. Means when you see broadly how coal will look like. Based on that, you can classify into proximate analysis or ultimate analysis. Proximate analysis is when coal you are burning, first what it comes out? Let us say coal you are burning. What is the first instant it will come out? What material will come out? Water vapor. So moisture will be liberated. So based on that, so that is the moisture. That is nothing but H2O, whatever I have indicated over here, that is the moisture. So first it will go. Then what comes? What comes out? Then what comes out? Volatile matter. Hence it will be burning out. So that is volatile. Then left with what? Then whatever the carbon, fixed carbon we'll call it, that we are written as char actually. So that is what left. Once the carbon fully combusts, then it will be leaving with ash. So based on when you start combusting this fuel, what all the processes are coming out, what all the elements are coming out, based on that you can classify into 4 types, and that 4 types are listed in proximate analysis. So each and every aspect of this will have a greater significance in combustion. If you take, let us say, volatile matter. Just now I have told you that how volatile matter is important for combustion. So in order to start the combustion, that is what required. Moisture means higher the moisture, combustion efficiency will be very less. Then you can talk about char. Char is fixed carbon. So higher the fixed carbon, higher the calorific value. So that is also important. Then we will go to ash. How it is important for combustion? Because ash is high means what is high? What is there in the ash? Carbon already I have removed. What is there? Huh? Somebody told silica, that's good. Silica content is. What happens when silica is there? Silica is having a property called abrasive property. What abrasive means? It will erode the surface. So in heat transfer in furnace, we will be having lot of surfaces. and from through this fuel gas will be flowing. When it is flowing, it will erode the material. So when it erodes the material, what happens? Heat transfer will not take place in a proper way, and you have to replace the tube frequently. So all these losses will, and we will have a number of losses that we will see later. So these are the drawbacks of each and every and usefulness also. Next, please. Then finite analysis we'll call it ultimate. Ultimate means you can break it into elemental form: carbon, hydrogen, oxygen, sulfur, nitrogen. In this, I have already talked about carbon, hydrogen, also like H2O. We'll talk about O2, oxygen. What is the useful oxygen? How oxygen is very useful for combustion? What happens when oxygen is more or oxygen is less? What happens?
Supporting the combustion.
Supporting the combustion. Complete combustion. Very good. So, if a higher content of oxygen is present in the coal, what happens is whatever the oxygen you have to give it to the combustion system will be very less. So, your entire design will be come down. What happens? Your fan design will be very less. Your fan, duct, other, all systems, whatever is related with fan will be very less. So, this results into reduction of components. Next. This is a typical code. Why I have placed this whole picture is because when I have attended one of the class, when I talking to my students, I have told about something about rice in some context. Actually. Then they asked, what is rice? So when you go to some urban areas, children are so grown that they are not aware of what is rice. So school also we are not seeing. Actually, we are living in a closed environment in ACs and other places, so we are not able to see coal. This is a typical coal how it looks like. Next page. So these are the typical applications. Steam engine will use heating, cooking, and iron, steel. In this iron and steel industries, the major portion of coal will be used. Then it comes to thermal power. Next page. Then we'll go to actual combustion process. What happens? Combustion is nothing but a very simple process called oxidation. This is one kind of special kind of oxidation, where what happens in a closed environment, in a special condition, the combustion will be taking place. So combustion is what it combusts fuels like coal, oxygen, gas, any other thing, natural gas or any other kind of gas. So how this combustion will be stabilized, how it will be proceeding. This depends on the flammability. So how you are able to ensure the flame. So whether you are making it too stable or whether it is fluctuating, all these things depend on some of the factors. Like let us say coal, how you are converting into a gaseous form, how fine you are making. Anything in order to burn, it has to be made into gas-like form. Then only it can burn properly. So that is the first thing which is required for a good flammability. Then it is called nature of fuel. Means whether the fuel is combustible, means volatile matter is high or low, whether it is high moisture content, high or low, whether it is soft or hard, all these things matter. Then it comes to quantity. How quantity will matter in a combustion? Because whatever the heat releases should be proportionately to whatever the quantity you are taking. But in combustion, what happens? Let us say you are sending some amount, X amount of coal, and then you are sending Y amount of coal, which is required as per stoichiometry. So that is what you are inserting. When you are inserting slightly excess amount of fuel, what happens? Whatever the flame generated will be quenched. So that in turn affects the combustion. So what you can do, you have to present coal and air or whatever the mixture you want in a proportionate. That is why quantity of fuel also matters. Next. So these are the important stages: ignition, combustion, stability, completion of combustion, and how it will take place in solid and liquid. I have already talked about ignition. Ignition means when I take any fuel, first it has to reach certain temperature. Then only it will start burning. So initialization of fuel or making the fuel to combust, that is called ignition. Then we will call it combustion stability. That we have already discussed. What is a flame? What is the flame stability, how can be ensured? It depends on what are those things will be come under combustion stability. Completion of combustion means you have to give enough time for the coal or fuel, whatever we are discussing, to have in the furnace zone, heating zone. It should be stay for sufficient time in the combustion process so that it will completely combust. If it is not completely combusted, what happens?
Carbon monoxide.
Carbon monoxide. Completely, it is not completely combusted, it will lead to carbon monoxide because oxygen availability is less, so it will form carbon monoxide, that is very dangerous to health. So those things. Not only that, when it is not completed, completely combusted, it will not liberate the energy what you require. So those things are drawbacks. Next. So this is the whatever we have already discussed. Only we will see in a detailed fashion. Next. So this is the process. It goes. First it will be released moisture, then volatile matter, that is called devolatilization. Then combustion of char will be taking place. Then it will form ash. That ash will be two types. One is fly ash, one is bottom. Bottom ash means the furnace it will be dumped onto the bottom of surface. Fly ash means it will be flowing in the atmosphere. So this is the typical how it will take place in a graphical manner. So total combustion process to take place, it will take around 1 to 2 seconds. So that is very, as far as we are concerned, it is very less time. But within this time, will everything has to take place. Means how fine you are making, how how fine you have to make that particle so that it will completely combust. That depends. So that is what the importance of this time. This time is called residence time. So how long this fuel will reside in the furnace zone or in the firing zone. That is. So what are the processes involved? Preparing the fuel and air. Preparing the fuel means you have to, let us say coal will be there, a lot of impurities will be there. You have to wash out all those things. You have to prepare the fuel. Which coal means you have to make it fine particles and what is the amount of required that you have to make. All these processes are called coal preparation or fuel preparation. Similarly, air also you have to remove all foreign particles from the air and you have to prepare. Then you have to make it into elemental form so that it can burn properly. Then the proper amount also you have to ensure whether how much coal is required, how much air is required. That we can you have read I think all these things. Let us say if I take carbon content, carbon will react with oxygen, C plus O2, CO2. So how many moles of carbon is required for how many moles of oxygen? So how many moles of carbon dioxide? From there what you are getting, what is the oxygen required from everywhere you will be getting from elemental analysis. That can be used to find out the required amount of air and fuel factor. So that is called right mixture. Then this whatever we have generated so far is only heat we have generated. Then what you have to do? We have to transfer this heat to the where? Water. Why we have to transfer it to water? Converting to steam. Then what happens?
They are expanded in turbines.
Expansion means what?
Converting the heat to mechanical work.
Mechanical work will be. And this mechanical energy will be transferred to whom? Generator will be coupled. So there what happens is this mechanical energy shaft will be rotating. That will be placed in the magnetic field. That will in turn generate the electricity. And that in turn is connected to grid. So from there will be. So that is what I was next. So this is the typical how coal is flowing through feeder, then it goes to mill. From there it goes to each and every corner of the this. These are some physical processes what are involved in the combustion process. In order to have a complete combustion, not only fine particles is enough. You have to have a turbulent flow. Turbulent means uneven motion. Anything else? Zigzag motion. Higher velocities. When you say, let us say you are having a cup of tea and you have poured some sugar in it, what you will do? First, what you will do? You will stir it. Why you are stirring it? Mixing. Why you are mixing it? You have to make homogeneous mixture. Then only it will not, we cannot different. Same thing we are doing here also. This is nothing but a very simple process, but in a bigger way we are doing here. Next. Then what are the different processes involved in the combustion? One is convective and radiative. Convective means what? What do you know about convective heat transfer? Between? Anywhere. Radiation also between two mediums only. Conduction also solid to solid only?
Solid to fluid media.
No need to be.
With contact.
Contact. Everywhere contact will be there. With conduction, let us say it's contact only.
Solid and fluid medium. Bulk motion between.
Heat transfer through the movement of particle is called convection. It is no need to be a solid or no need to be a liquid. It can be anything, but heat has to transfer from one media to another media through particle movement. So, this convective heat transfer depends on the particle's velocity. Higher the velocity, what happens? Higher. How you can say higher velocity, higher heat transfer? Can you give me one example? These are all various concepts. It is not example. If you let us say one fine example, I will give you. You are in a winter. You are going on a bike. Let us say you are going very slowly. How much coolness will be compared to the low? When you are picking up speed, what happens? Why? What is happening there? You are increasing velocity means heat transfer is. This is coal and air mixture. No? If it is not proper, then what happens? Uneven heat release, because you are entering coal at particular point of time, then air will be entering at other point of time. So there will not be proper combustion. So it will lead to uneven heat release. Then distribution of excess air, higher amount of excess air will be released. So what happens? You cannot get the required amount of heat because actually stoichiometric air is required for in order to have a proper combustion. But when the amount of air is more, what happens? It will quench the fire. It will quench the heat, whatever is available. So you will not get the amount of heat you require. Then unpredictable NOx, because oxygen is more means NOx formation also more. Then how to rectify all this thing? What you have to do is next slide. This is the typical coal pipes layout. So in this particular layout, what happens is, if this particular mill is there, this is giving coal to the all four corners actually. So what happens when you compare this pipe to this pipe is very shorter pipe and this is a very lengthy pipe. What happens when coal goes through this one, it has to face maximum resistance. So what happens, whatever the quantity flowing through this particular burner will be very less. And here it is more. So what happens is whatever the firing zone you want to make it, it will be shifted towards this one. So here the local heating will be more and here the heating will not be proper. So this will lead to uneven heating. So what we are doing is we will be placing some orifices so that we will be equalizing the flow. That is what we have discussed in the earlier. So this is typical burner, how it looks like. Center of burner will be this. Here one igniter will be placed. This will give the initial ignition energy required. Then we will be having a scanner which will sense the flame, whether flame is there or not, whether it is stable or not, any flickering is there. Those. Next please. Then we will come to oil firing. So oil firing, when coal cannot combust by itself, it has to have some initial ignition energy. To provide that initial ignition energy, we are having oil. In that oil also we are having two types of oil, as we already seen, LFO and HFO. LFO means low fuel oil. Low fuel oil means that is it will have very less viscosity. So it need not to be heated to reduce the viscosity. So it can directly make use of it in the combustion. Then these are all the typical processes. This you can go on your own, pumping, heating and all these things. Then filtration to remove the fine particles, dust particles. So that what happens, this will not be flagged in the pump. this thing. Then we have to maintain, in case of HFO, you have to maintain the viscosity. Because why we have to maintain the viscosity? Higher the viscosity, this cannot be atomized into fine particles. We have seen that when you make it very fine particle only, it will lead to combustion. So making fine particles depends on both pressure as well as viscosity. Higher the viscosity is not conducive for atomization. So you have to bring down the viscosity as well as you have to increase the pressure. Pressure increasing means what happens? The pressure energy will be converted into kinetic energy. So that leads to higher velocity. So it will make the fine particles into mist kind of thing. So that will lead to combustion. Next please. So this is the atomization, spraying the fine particles, then better mixing, viscosity reduction. These are all the things we have already discussed. What happens when it is not made into fine particles? Bigger particles will be there, combustion will not be taking place, heat release will not be there, and even means carbon monoxide and other pollutants will be released. So these are all the drawbacks that also. Oil recirculation, because oil always should be recirculated because it will get the at higher temperature, because viscosity will be very high in case of HFO. In case of LFO, it is not required. Then we will be having vents because it will be forming some vapor kind of thing. So it should be vented. Then we will be having drains. So what happens whenever there is a collected some material, should be drained out. Whenever you want to use some particular system, you can drain out. Next please. These are all the typical burners we are using. What is burner? How? What type of burner? Tangential, wall burner. Tangential means all four corners you have seen in the previous diagram. The four corners. Wall burner means with the front wall or rear wall, whatever the type of wall, there you will be placing the burner. Next please. Then what all the modern burners will consist of? Let us say separate envelope for coal, air and all these things. You will be having separate compartments for each and every. Earlier burners will have all the things put together in a particular burner. But these are all the separate. Then secondary air control means how much air has to be going inside and what place it has to be. All this will have an effect on combustion. Let us say you are inserting air into the very high temperature zone. What happens? It will lead to NOx formation. Because NOx formation depends on two conditions. One is very high temperature and other is excess amount of oxygen present. So if you can remove these two conditions from the combustion, you can reduce the NOx formation. How you have to reduce? Secondary control adjustment, other things, placing of secondary, all these things. Next. Then scanner to detect the flame. Then tangential bearing. Next. Next please. This is the typical wind box, how it looks like. Next please. Next. This is compartment wise, where oil compartment will be there, where air, coal compartment, how it looks like. Next. This is the type of igniters, oil igniter, gas. Why you have to use different type of igniters? Because different fuel will have different self-ignition energy. At what temperature it can ignite, that will vary depending on the fuel. So based on the fuel, we will have different igniters. Next. Then devices, what are the flame sensing devices? UV scanners, IR scanners, because each and every fuel will give different kind of flame, which will have different frequencies. So based on that, you can have different flame scanners. Then these are all the pollutants will come out of the combustion process. NOx, SOx, CO2, CO and particles. Next. So what are the emerging trends in the combustion? Earlier, whatever burner we are using, we will be using only one fuel. But now we are using multiple fuels, so that we will have a flexibility. This is what the trend now it is coming up. Then low NOx burners, because we have to reduce the NOx level to meet the emission requirements. Then longer guarantee period, because ash is there, no, it will erode the material. So what we are doing is, we are selecting some higher grade materials. We are designing a system in such a way that it can withstand with high ash content. What we are doing is, we will be placing, let us say one coal pipe is running and it is taking a big turn. What happens when coal is taking a big turn? As per the Newton's first law, what happens? What is the first law of Newton?
Cannot change its state.
Body is remain. Only rest. Same motion. Whatever motion it is there in the same motion, it will go. So when I am making a turn, particle will try to go straight only. It will not turn. So you have to make it turn. So what happens when I put a bend? It will try to go straight. So what happens? It will try to go and hit the surface. When it's hit, it will erode the material. So what I will do is at that particular place we will be having some ceramic coating or some liner we will be using. So that what happens, we can reduce the damage to the surface. So all these are the improved design features. Then new devices like thermal and other things will be using. Then these softwares will be using to make how combustion process will be optimized, all these things. Then initially we will be having CAD design, so that we can assemble each and everything and we can see whether it is really feasible, whether it is really implementable, all these things. And then next. Then NOx formation and control strategy. Next. These are all the things, explanation will be done in the later part. I'll simply go through it. 5 minutes, only 5 minutes. Overfire air means combustion chamber will be there. No? At that chamber only we are inserting air normal. At that chamber what happens? The temperature will be very high. So what happens? NOx formation will be high. So in order to reduce that, what happens is from X quantity it has to go means from X I am taking some X1 quantity, that is a small quantity, and I am firing over it. That is called overfiring. So that I am making sure that this high temperature zone is lack of some amount of oxygen. That is called overfire. So that we can reduce amount of NOx formation. Then low NOx burner. Here also staged combustion will be there. So through some 2-3 stages you will be sending the air and you can reduce the NOx. Then NOx formation, all they are put. Reburn means again you will be using the fuel, again burning. Whatever is not burned, again you will need. This selective catalytic reduction is next step. Here what you will be doing is in a separate chamber, whatever the fuel gas you are allowing it to atmosphere, you are treating with ammonia plus oxygen in the presence of one catalyst called titanium oxide or vanadium pentoxide. So what happens? This NOx will be turned into nitrogen. So that nitrogen is not. So in that process you can reduce the NOx. Next is. So this is the typical where the NOx will be formed. Let us say here this is the firing zone actually, but here you are allowing the overfiring. So that here the temperature is high. Here when it goes to till this place, here the temperature will be reduced. So oxygen availability is less. So NOx can be reduced. Next. These are all the various stages, how cost effective, how it is. Next. This is the overfire, whatever we have already discussed. Next. This is what rather bigger term, how overfire is. Next. This is when oxygen overfire increases, what happens? NOx level will decrease from 300 to 200. At the same time, excess air also increases. So after certain point of time, this excess air will lead to more NOx formation. So you can up to 13-14% only you can allow the excess air. Next. This is the stage comes next. This is what different low NOx burners, wall pipe burners, tangential burners, where you are using. In tangential burner, what we are using, closed coupled overfire air will be attached to the wind box. That is called closed coupled. Separate means the wind box is separate and that overfire air is also separate. Next. This is what roll combustion system. In a very simple term. I have not gone into very details. I go into details will take time. Thank you.
Thank you, Mr. Shankar Naik, for your lucid presentation about the basics of coal combustion and pulverized fuel combustion. I think he has to excuse us for not giving sufficient time, and within that time, what all justification he could do, he has made. But what Truckstep has made is only to have kindling effect in you, so that you can pick up from this thread. Maybe you can request him for an invited lecture in your own college. And I think he'll be happy. On his behalf, I am requesting him to accept your request, so that your knowledge will be enriched. And there is no limit for your interest. And depending on interest, I think he will be able to help you. With that assurance, I just want the participants to raise a couple of questions if you have in your mind. Please. We will spend some 5 minutes only, so make it short and sweet. Please.
Because anthracite is not used for combustion purpose because 90% of carbon content is present, but only 10% of volatile matter is present.
Audible? Coal is having 90% of
Carbon content, sir.
so remaining 10% only has to go for the others. Like what all other things? Volatile matter is there.
Foreign countries in Indonesia and New Caledonia, that is near Australia, just supplying 125 megawatts CFBC boiler, 2 numbers, that is under direction. Just contracted 28 number of CFBC boilers. This is a typical fuel analysis. My friend just explained you well what is that. I don't need to go into this. This is a limestone analysis, how it looks like. See, if you see the limestone analysis, what calcium oxide is 53.7, the carbon dioxide is 37.6. The typical analysis I have given you. About 90% is a calcium carbonate. The rest of the things are what is silica, aluminum, and all this. This is what is used for sulfur dioxide absorption. Well, just telling you, one of the largest boiler in operation is a 460 megawatt CFBC boiler in Poland. It is supplied by a faster wheeler and it is in operation. See, the boiler height is about 48 meters is the height. 48 meters. You can store anything. You can just think of it. 48 meters is the height. Width is about 26 meters and depth is about 10.6 meters. It's got 2 sides. You've got a rectangular cyclones. Particles is a combustor. Particles are going to this side as well as this side. Collected here and then recycled back. This is what is perfect. This is a combustor. This is a backboss. This is a tubular agitator. This is an electrostatic precipitator. This is in operation, and they have got a very stringent environmental goals. Very stringent. The next slide. Yes, show the values. They are in European countries. They just mentioned what is the level of SO2 emission, NOx emission, CO, and other particulate emission. It is monitored on daily basis. The Pollution Control Board insists on all those things. Typically, so many milligrams per normal metric cube is allowed. Sulfur dioxide, only NOx is in the form of nitrogen dioxide, only so many milligrams. They insist on it. They stick on it. It's not in the numbers given for publicity. They just this is big practice now in the country. They are using a very inferior variety of coals, but in spite of it, they maintain this particular. They use local bituminous coals, coal slurry, biomass also they use it. They use it. A small, about 2 to 3% biomass they use it. Yeah. This is still data. This is what China. Chinese are rapidly expanding their power station. You cannot just imagine it. Every year you can say that whatever whatever UK is having, so much of power they are installing every year. Here they are right now commissioning a 600 megawatt CFBC boiler. Right now they are doing the commissioning. This 600 megawatt CFBC boiler. They are just doing. This is a supercritical boiler. Schematic of it is contains about 6 cyclones. 3 this side and 3 on the other side. Just telling you particular one. They are also mentioning about that SO2 emission, NOx emission. What is that? All those things they are using. They are using the inferior variety of coal. Their ash content is also high, like what we have faced in India. And ash content is also high. In spite of it, they have done a lot of work on this laboratory work, modeling work, CFD analysis, all those things they are done. Based on this, they designed the boiler. constructed it. They are right now doing the commissioning part. They have as many as 30 number of 300 megawatt boilers are in operation in China. 30 numbers. In India, we don't have even one single 300 megawatt boiler. We are right now doing a 250 megawatt. That is only we are commissioning it. So 30 numbers are already in operation there. They are in a well advanced state now. Worldwide also, they are the first one to install 600 megawatt boiler. This is great. Okay. Thank you very much. Need any?
Mr. Rajvel, ranging from fundamentals of fluid combustion up to latest CAPC technology. Thank you very much. And I request the participants, if you have any questions, you can raise.
Thank you, sir. Sir, weight, that is density level is different from one place to another, where we are getting the cool, right? In FDC, that is fluid combustion, the particle weight is much more important because we have to give the air velocity according to the weight of the particle. So, for an Indian coal, we have high dense coal, right? We have high dense coal, that is the weight is more. But at the same time, the calorific value is less. So we don't need much air, right, to combust the coal.
For any fuel to burn, stoichiometric quantity air should be admitted into the combustion. Okay. For fluidization aspect, can you able to hear?
Yeah.
For fluidization aspect, the fluidization we have to ensure the minimum fluidization based on this particle size. If it is a heavier one, we have to use a lesser size particles. The particles which are there is having a lesser density, then we can think of a coarser size particle. But for that matter, in India, this bulk density, or there is even the particle density of the coal, varies only between 2,200 to 2,500 kg per meter cube. This variation does not affect in this particles ranges of 5 to 6 millimeter, or the average size what we use it is only between 800 microns to 1 millimeter size. That is the average particle size. Maybe we talk about upper size is 6 millimeter or 8 millimeter. Average particle size is between 800 microns to 1 nano particle size. This size range, if we use it, we don't face any problem in fluidization or any combustion. Okay?
One more question. Actually, the bottom ash and fly ash we have.
I just would like to supplement what Mr. Rajvel has told. For the basic question what you asked about the strategy for the air requirement of high ash coal. Irrespective of the method of combustion, your theoretical dry air is the same. Whether it is method of combustion is stoker fired boiler, which is the first generation boiler, or APC boiler, PF boiler, second generation boiler, or third generation APC boiler. Irrespective of the type of combustion or method of combustion, your theoretical dry air requirement is same. That is decided by your composition of the air. Right? Okay. With respect to strategy, maybe in stoker, they were firing with very high excess air. Maybe 30%, 40% excess air. That's why that stoker fired boiler is less efficient. The efficiency will be less than 50% only. Whereas in PF, the efficiency will be around 88%, FPC also around 88%. So what strategy we adopt in FPC is, the excess air quantity can be less. Am I right, Mr. Rajvel? Yeah. Excess air quantity can be less, say 10%, 20% is sufficient because of the intensive mixing of the fuel and the air. Whereas in PF, it is around 20%. I mean, right, Mr. Rajvel? 10%. This is the PF boiler. Okay. So that is the latest technology. Whereas in stoker fired boiler, it is around 30% or something in the excess air. In PF and APC, it will be around 10% or 15%. This is the strategy you are adopting for the compression of the high ash fuel in the latest compression methods. Okay, next question please.
Thank you.
From NIT. Sir, my question is, you are producing 800 megawatt boiler. 800 megawatt. In which technology you are using?
800 megawatt and more, we are using supercritical technology, where supercritical point for a water and steam. You'll be
Means
having
fluid
fluid
combustion means fluidized bed combustion you are not using?
No, pulverized coal combustion only. We are using that concept only. We are adapting for supercritical boiler. So,
And second question, sir, why you are considering about that circulating fluidized bed combustion? Why not about fluidized bed combustion you are considering? And what is difference between them?
Okay, this circulating fluidized bed combustion are preferred in India mostly for sulfur content fuels. Sulfur content fuel to absorb the sulfur dioxide. This lignites available in western region, that is Rajasthan, Gujarat, all these states, you find a lot of lignites with sulfur, as high as 5 to 6% the sulfur is there. We supply boiler for high sulfur content fuel. In western countries do. This particular technology, circulating fluidized bed, is more predominantly used only for sulfur capture, and the fuel containing a high nitrogen content fuel, for that they use it here, this particular technology. The PF is a well-established technology, no doubt, and we have number of 500 megawatt boilers, 660 megawatt boilers are out there. Here in India, we are just catching up the technology. 250 megawatt boilers are being used here. Only, as I told you, 460 and 600 megawatt, only 1 or 2 boilers have come up worldwide. It probably will take little more time to accept even for coal firing in India. You understand?
So then what is the problem you are facing? Why you are not producing 600, or why you are not going for 300 or 400 megawatt boiler? What is the problem you are facing by that using of that fluidized bed combustion?
The fluidized bed, we are right now commissioning 250 megawatt CFBC boilers in Neyveli, and we are constructing another 250 megawatt in Ahmedabad. That is in Gujarat we are doing it. In Bhavnagar we are doing it.
So my question is, why you are not going ahead of this?
Yeah, it is only a question of time. It is only a question of time. It is only a question of time. You have to just wait.
Mr. Arun, basically you have raised two valid questions. One is 800 megawatt, which is the type. Right now, PO technology maturity has gone up to 1000 megawatt. Okay, design wise. Operational, soon we will be finding 800 megawatt. Whereas in APC boiler, in India it has gone up to 250 megawatt. That's where you asked, why not PFPC itself for scaling up. Am I right?
No, he's more interested is, from what I gather,
Yeah.
is that China is going at such a rapid pace.
Yes.
So what is keeping us from going at that? Am I right? That's what your concern is.
Yes, you are right. China has gone up to 600 megawatt. We have gone up to 250 megawatt operational. Constitution design, I think we are ready with. No, what is the level you have gone up to?
Right now we have gone up to 250 megawatt. And we have designs right now, we have up to 400 megawatt, 250 megawatt designs we have it. Just waiting for an opportunity to fetch an order and then commission the ball.
Probably, I think if you were to tell him the economics behind it, he would understand it. I think he feels that we have the technology, but it's
Yes,
more than that.
acceptance.
It's beyond the
Acceptance.
technology.
Yes.
It's also the economics that matters.
See, there are two aspects in market. One is technology maturity, another is acceptance by customer. The second part, I think, we have to care. Hope you have answered. Right. Any other question, or you would like to conclude? So, irrespective of the subject, you will find the duration will be short or more. What is your feeling? Both the sessions, it was short or more? Pardon? Loudly. Short only. Okay. On your behalf, I pass on this message to the organizers structure. Okay. Thank you very much. And I have raised one question at the beginning of the session. What is clean coal technology? Can I hear from one of the participants, please? I'd like to know from you what is clean core technology. Any one of you? Yes?
Maybe they would answer after these two sessions.
These are all called clean core technologies. These, among the 4 clean core technologies, 2 you have already heard. 2 more you are going to hear. Sorry, 1 you have heard already. Supercritical technology, ICC and oxygen combustion will be hearing now, right? At least now you can tell. If you are not able to tell now, at the end of this afternoon session, I would like to hear from you. Then only it's justified. Okay? Please. I would like to pass on to Mr. Prasanna.
Thank you, sir.